Hi everyone, welcome to Mrs. Shin's class. Today what we're going to learn is how to differentiate the exponential function. Okay, so exponential function, it's always y is equal to e to the power of x, where e is an irrational number of 2.71 la da da da, just like pi. Okay, but this exponential function is a very interesting function because it is its own derivative. So if I differentiate y equals e to the power of x, I'll get the same value, still e to the power of x. Okay, let's have a look why this is like this. Okay, so people, this is the graph of exponential function. So this is y is equal to e to the power of x. Okay, right, and this exponential function is an interesting function in that it is its own derivative. So dy over dx is still e to the power of x, which is the same as the original equation. So have a look that y is e to the power of x, this curve, right? Okay, so if I have a look at this one, where when x is 0, the curve, the corresponding y value is 1. And when x is equal to 1, the corresponding y value is 2.7 la da da da, which is the value of e. Okay, then let's draw the tangent curve to this. Okay, touching one point when x is equal to 0. Okay, but still, if I put x equal to 0 and find the gradient is still 1. Okay, because if you over here, if you put 0, anything to the power of 0 is 1. Yeah, and this one also, if I draw the tangent curve, and I can see that the gradient is 2.718 la da da, because e to the power of 1, if I just replace x to 1, then it is just the normal e, natural value e. Okay, so therefore we can say that even though we differentiate the equation the exponential function, it's giving the same value. Okay, but then as soon as I have something in front of x, or if that becomes another function, then we have to use the chain rule that we have learned in the previous lesson. So if I differentiate this one, okay, just like above, where e to the power of x was just the same thing, okay, it's the same. E to the power of ax, I'm just keep it the same, like this, but I'll differentiate what's in the power. So if I differentiate ax once, then x will disappear because x is to the power of 1, and I'll only leave a. Okay, so a will be multiplied. So this one I can just rewrite a e to the power of ax. This dot is not decimal, it's multiplication. Okay, so have a go at doing this question. Alright, first of all, I need to differentiate it. Okay, but then this will stay the same, right? But what do I need to do? I need to differentiate the power and multiply it. So if I differentiate x to the power of 2, it's going to be 2x, right? Okay, then I just need to rewrite the equation like this. Okay, so this will be the final answer. Alright, then how about doing this question? Even though I differentiate, it will still stays the same, but I need to differentiate the power and multiply it. Okay, so if I differentiate, what would I get? Yep, just 5, isn't it? So if I rewrite the final solution, just like this. Okay, then what about this question? 7 is just numbers in front. Okay, so even though I differentiate it, it will still stay the same, and I just need to differentiate the power and multiply it again. Okay, and I'll just write the final answer. Yeah, here you go. Okay, then how about this question? It's all mixed up and I have 3 different terms, right? In this case, you're just looking at each term and differentiate each term. So don't look at all the others, just look at this one. How would you differentiate this one? Yep, just like this, wouldn't it? Right, because you're just writing whatever it is. Yep, and you differentiate 2x is just 2. Okay, then if I differentiate the squared terms, I'm going to write everything as it is. Okay, and I multiply by whatever I differentiate the power. Okay, like this. And the last one, okay, it's minus. So therefore I'm going to keep them negative. Okay, but then 1 over x is x to the power of negative 1. Yeah? Yeah, so this is exactly the same with this. And I'm going to differentiate the power and multiply it. Okay, so this will be your final solution. Right, so negative 5x, e goes down, get rid of negative. E to the power of negative 1, this is the power, so e to the power of 1 over x in the power, and x minus 2, then you flip, x goes down to the power of 2. Okay, so this will be your final answer to this question. Right, this looks a little bit more complex, but let's have a look. Okay, I have square root in the power, so I'm going to put it as to the power of a half, like this. It's the same thing. Okay, then now I'm going to start differentiating. Right, first, even though I differentiate, I'm going to keep everything what was in the original equation, and then the power, I'm going to differentiate it and multiply them. Remember, here's another chain rule, okay? It's in it's in brackets, so therefore I'm going to pull this down, keep the bracket and minus 1 to the power, so, okay, like this. And once again, I have the bracket. So this one, inside whatever's inside the bracket, I'm going to differentiate once again and multiply, which is 2x, right? Okay, this is how you differentiate this function. I'm just going to multiply and simplify my answer. Okay, like this. Right, coming again. So I've got the equation y equals whatever. Okay, I have square root. I'm going to put it in power form. Alright, then I'm going to start differentiating. Once I differentiate, I'm going to keep whatever it has in the original equation, keep it the same. The power will be differentiated, so half goes down, and I'm going to keep the bracket, minus 1 from the power, then which I will get this one. But once again, since I had that bracket which has not been differentiated, so I'm going to differentiate this, which is 2x. Okay, and then finally just simplify your answer. 2 disappears. That, so x times whatever that is the same thing with this one. I have a negative power, so I pull it down. Okay, let's have a go at doing the last question. Again, I have square root. Okay, I'm going to put it in power form so it's easier to work with. Okay, then have a go at differentiating this. Again, chain rule, I have brackets, so I'm going to bring this one down, minus 1. Okay, but then I have to differentiate what's inside the bracket. So 1, if I differentiate it, it's going to be 0 disappeared. And this one, if I differentiate it, okay, it's going to be still the same. 2e to the power of ax. And then remember, you need to differentiate the power again. Okay, so if you differentiate the power, it's just going to be a, right? Like this. Okay, and this will be a final answer. Okay, so today we had a go at differentiating the exponential function, right? Please remember this rule, and I want you to have a go and doing some more practice in your book. Okay, then I'll see you in the next lesson. Bye-bye.